with respect to our support for smart NICs. So please join me in welcoming Joseph.
Thank you. So my name is Joseph Kasparakis. I'm software architect working for networking platform groups in Intel. I'm looking specifically to SDN and NFV and looking to do optimizations on the data plane and with some view of the control plane as well. I think this is the perfect time for me to put you to sleep. I'll keep quiet. You had your lunch. You want to relax, so I'll try to keep quiet. But for those who want to listen into this, this is a report out to what has been done in the community, in the Tungsten Fabric community. Intel participates, but it's the whole community that drove the actual offloads in the NIC and the optimizations for the vRouter. So before I start, I would like to ask, because there is, at some point, there are some code graphs and things like that. Who wants to get a little bit more detail and who wants a little bit less? Please put your hand up if you want more details on the code. Okay, and put your hand up if you want less details on the code. Okay. There has to be someone. Great, okay, so we'll do a little bit more details then. So, as I said, that was a community drive. We got together and we started looking on how we're going to accelerate the vRouter. The answer was with SmartNICs. The first question was, what do we mean by SmartNIC? Because the smart part can vary quite a bit between the different network interfaces. So we said we're not going to be too hung up on what is smart and what is not. As long as it accelerates the vRouter, that's what we want to do right now, as long as it accelerates the data plane. So we started by breaking into two groups. We started some design meetings all together, and then we broke down to two different groups. One looking at doing partial offloads, meaning taking some metadata from the NIC in order to accelerate lookups in software tables. And the other group was looking into running the whole vRouter, if possible, inside the network interface. These were the two approaches. From the partial perspectives, it was Mellanox and Intel who looked at this problem, where on the full offloads, we had Cavium, Marvell, Netronome, who else am I missing?
Mellanox.
No, Mellanox was the partial offloads.
Oh, I see.
Yeah, we worked together on the partial offloads. And AT&T was there to help with extra slides and to break down the problem and help the actual discussion moving forward. So these were the main contributors. Of course, it was discussion between others as well, but the main contributors were there, and as I said, we broke into two designs and two different approaches. Keep that in mind, and we'll talk about these two approaches right after this. So I wanted to give an overview of the Tungsten Fabric stack and specifically the vRouter. Although I think pretty much everybody in this room is already familiar with that, but I want to go through the motions because there might be a few who are not that much. So at the top we have the orchestration, which can be OpenStack, Kubernetes, or anything like that, any container engine. Then we have the Tungsten Fabric controller, which is the network controller. And underneath we have the compute nodes that are running the virtual router. This is the data plane. Now, comparing and contrasting an OVS setup, there are many familiarities at high level. You still have the orchestration, you still have the controller, and you still have the data plane. If we drill into more details, the devil is hidden there, as we all know, and I have at the right, specifically for the vRouter, some characteristics that it has in its architecture, which make it quite different. First of all, it operates on layer 3, where OVS is operating on layer 2, and the vRouter has all these tables that is using, rather than flattening rules and running them in 2 big tables. The vRouter chooses to have several lookups, much smaller lookups, and I have listed them there. In terms of tunnels, the vRouter supports MPLS over GRE, MPLS over UDP, VXLAN, and by the way, if anybody wants to ask a question or add something that I might be missing, please raise your voice. And the control plane is running through XMPP, which is an XML-based protocol, where OVS is using OVSDB and OpenFlow. The control plane, I think the choice of the control plane really depends on the actual architecture of the vRouter. But again, we have many people from Juniper who can prove me wrong for that, all right. So this is the overview of the architecture of the full stack, and specifically what components the vRouter comprises of. So here is why I asked the question at the beginning. But I guess I cannot go very far, can I? Yeah. Okay, at least I want to be able to see this. So,
you know, we can probably hear you without the mic.
Yeah, you can just project.
Yeah? Okay. Let's try that. I'll just turn it that way. All right. So, at the beginning, this is the generic RX path into the vRouter, right? We have VRDPDK LCore launch, which is the function that launches the LCores of DPDK, and there it uses the QRX ops, which actually is a function pointer, and it's either implemented with RTE port ethdev reader RX for physical interfaces, or DPDK virt.io from VMRX if the packet, the entry point is the VM, because you can have both ways. Then we have the VRDPDK LCore. By the way, this is obviously a simplified version. There is quite a lot that I'm not talking about. But at least this gives a pretty good picture of how the vRouter works, so that we can all understand how the offloads are working. So at that point, the mbuffs, the DPDK mbuffs, the buffers that contain the actual packet and the metadata, are translated into VR packet, which is an encapsulation that includes the mbuff and other metadata which are required for the vRouter. Then the path is again splitting, depends on what interface we're coming from. We have the ETHRX or VMRX, which take us to the fabric input or the virtual input. So at this point, there is an inspection inside the packet, so we know what type of packet is the first set of headers. And I'm omitting all. This is specifically an example for MPLS over UDP input path. So first is the layer 3 input, where we have the flow lookup, of the encapsulated packet. Then we are the VR flow forward. This is where the decision is made if the packet is going to be dropped, sent to the agent because the table doesn't know about the packet, or it will be received by the IP receive function, where the layer 3 lookup is happening. Obviously, if it gets up to the agent, then the flow will be programmed and the packet will be reinjected at that point. After the layer 3 lookup, we have the UDP input, right? It's MPLS over UDP, and then the VR MPLS input. This is where the packet gets decapsulated, and the inner packet now is being sent again into VR flow forward. The inner packet now is either dropped again or being forwarded to the right virt.io and subsequently to the right VM. So this is the data path which the packet comes in and does one loop and goes again to the VR flow forward and then up to the VM after it gets decapsulated. So if we're looking at the modules hierarchy, at the bottom I have the hardware. This is the NIC, which has the same tables as the vRouter, or a subset of those tables. At the top, we have the vRouter with the agent. The agent, again, is the entity where the packet is being sent when the vRouter doesn't know what to do with it, which already coexisted when we started looking at the acceleration. And the vRouter has the same tables that I mentioned before. I'm showing them there. Again, the correlation between these tables and the tables down in the NIC can be either the same set or a subset being in the NIC. So what we have introduced is the generic offload module, which is actually using for the partial offload. The design was to use RT flow, which is a DPDK interface, which programs the NIC and allows you to do flow classification and flow identification inside the network device. Then obviously you have the NIC driver. So if at that layer I make an RT flow, then it doesn't matter what device I have underneath. I have abstracted the flow classification and the flow identification. And as long as that device supports these RT flow APIs, then it shouldn't really matter, and the NIC will start providing metadata that will allow me to skip the lookups that I talked about in the previous slide. Initially, for the full offloads, what we said is we're going to use the Linux TC, and we're going to have the Linux driver. And that will be the way to programming the NIC to run the full vRouter inside. So this is the contrast between the partial offloads and the full offloads. Towards the end of the design discussions, however, we had a proposal that came from Netronome. We decided to have one more interface, that green interface, in the generic offload module, where a NIC vendor can now introduce a proprietary, if they wish so, module and drive their network card through that interface and completely bypass the open source components, which is the RT flow from the PDK and TC from the Linux kernel. So with all these well, these are three options that actually we have implemented two, the RT flow and the proprietary module. With this approach, we should have currently support for Intel, Mellanox, and Netronome NICs. Not all of them, obviously. Those that fit this and those RT flows and this proprietary module is built for. The data plane now can be offloaded by the SmartNIC. In terms of the partial offloads, I said in general that we're skipping some functions. So I'm showing again the slide that I showed before with the lookups. So the benefit of introducing the generic offload module is that now we can do RSS for the whole MPLS over GRE and UDP and VXLAN packet. So now we can spread the flows into several cores rather than having only one core processing them, which gives actually a very good benefit because we can do much better parallel processing now. The RSS is a hash-based function which the NIC can provide as metadata, so software doesn't need to calculate a hash per packet that gets received. It can get it from the NIC straight away as part of the descriptor. And the outer destination lookup, which is in the mtry table, in those two functions, VR flow forward and VR IP received, can also be done in the software. The MPLS table lookup in VR MPLS input is also included and part of the metadata that come. And the flow table lookup is also the third function that we can skip and get the metadata straight from the network interface. So that's pretty considerable, thinking the whole data path that we had to go through and have several lookups, as I mentioned, because the vRouter has several tables to look at. Now we can avoid a big portion of that. With partial offloads right now, we cannot do encapsulation and decapsulation. So this has, we have seen some pretty good performance boost in our lab. I'm not going to share any numbers because it's preliminary data, but the picture is very, very positive. This is the partial offloads. The full offloads, obviously it's a proprietary module, and I have no knowledge to talk about and explain how exactly things are happening. If anybody happens to be here from Netronome, I would be more than happy to also hear if there is. No? Okay. The main idea, if I can represent that part, is that your lookup tables are mirrored inside the NIC, so you can run your whole data plane inside the device. So again, on the partial offload side, big benefit is the parallelism that is being introduced by RSS, because now RSS can work with the whole encapsulated flows. The lookups, of course, can be expensive, and that's why we see pretty good performance numbers by doing that. And also, another thing that you need to keep in mind is the cache utilization, which is way much better, again, because we're avoiding those lookups. So, saving from doing the lookup, saving cache from trashing the cache by bringing up those tables and evicting other data. And RSS allows all cores that we give to the vRouter parallelly do the packet processing. The current state of upstreaming all this work is we have the generic offload module in the Tungsten Fabric upstream Git tree. We're about to do the 5.1 release. It hasn't happened yet. It's not in the 5.1 branch. We're looking to see if this can make it into this 5.1 release. Most probably it's not going to make it for the 5.1, but most probably the interception point will be 5.1.1, which is in Q1 2019. The proprietary interface is in the Tungsten Fabric Gerrit and pending the final reviews. Any DPDK version that includes RT flow calls need to be incorporated if you want a specific NIC to have all the stack in place so that you can exercise the partial offloads. In this release, we're about to release with DPDK 18.5. There are some discussions about 18.11. If it gets pushed to Q1 2019, we might as well go with DPDK 18.11. These discussions are taking place in the technical committee meetings on Tuesday, 9 a.m. PDT. I'm acting chair of the technical committee, but we had meetings, initially weekly meetings also about the SmartNIC design, where we went through all this design cycle and we decided the options and we hashed out the details. It started by doing extra weekly 1-hour calls to drive all this work, and now we're at the point where it is bi-weekly and basically we're pretty much done with it and it's on the basis of if needed. And that is pretty much everything I had for you for today. If you have any questions, I will be more than happy to take them now. Yes?
One question. Is porting effort for offloading agent a separate project or is it incorporated as part of this?
Can you repeat the question?
Yes. So the question is if there is any effort to offload the agent. So what exactly do you mean by offloading the agent? Offload it where?
Actually moving it to the project.
So, okay, so having the controller talk directly to the NIC. I'm not aware of any approach like that.
Okay, I'm just wondering if it's part of your consideration for future work. Only because, for two reasons, OS independence and the other part is functional isolation between operating groups, graphical home compute and home networking. So it's a technical problem to a political problem.
Yeah.
But it comes up very
It's always
often
like
in
that.
enterprise environments, right?
Yeah,
That's why I'm asking, if you're going to do this work and the NICs are starting to become capable, whether or not that should be part of your consideration as far as the work.
So sure, that is an option. As you said, it's both technical and political, and what at least the technical committee should care mostly is the technical part. There are benefits in doing so and benefits not doing so. Software is always more flexible, so you can push the change much faster than if it is in hardware. I mean, we can start having now a whiteboard session and go through all these details. Right now, to answer your question, I don't think anybody has proposed something like that.
Because one of the things I see that comes up fairly often is having some independence from the host operating system, just from versioning and patching and all those kinds of things. Makes it look more like an appliance
Yeah.
easier because the dependencies on host OS is not trivial.
There are some NICs which has parallel cores and can run full-fledged
Yeah, there's
operating
starting to.
system. Maybe you can put the router agent here. And
Yes.
I'm not sure anyone tried.
Yeah,
As
there's
Joseph
some
Yeah.
NICs, but like I said, and as we look at the next couple of generations of smart NICs, I mean, more and more
Yeah.
are probably going to start putting our processors, right?
You're right, that decouples the whole thing from the host OS, but it couples more with the vendor, right?
Yeah, I just wanted to see.
Yeah,
if
yeah,
that's
yeah,
part
yeah,
of this
yeah.
discussion.
Yeah. Yes.
Joseph, did I get correctly that both RT flow and TC are partial offload mechanisms?
No. So RT flow is partial offload mechanism. The TC, we were thinking initially to use it to do the full offload. So be the reflector, if you want, for the packets that are sending the control messages to the NIC to program it would go through TC. The problem is TC is not ready for prime time for something like that. What we had said is that we're going to look at doing some prototyping and extend the TC and then take it to the kernel community in NetDev discussions. But unfortunately, the main drivers for that, which was Marvell and Cavium, as you know, now they have merged and they are not anymore part of these discussions. They don't have an interest. But that would be the open source way of doing the full offload. And then you can have all the NICs implementing the TC mechanism.
So, if I may figure, as far as I know, Mellanox, and we've been working a lot with that. As far as I know, TC and DPDK RT flow should eventually provide more or less the same APIs. The
Yeah.
difference is either user space or kernel space. Both of them can be either used for the partial offload, basically providing the metadata, or completely offload the flow handling, including advanced features like mirroring or other things.
Yeah.
The target, at least that Mellanox been driving along the way, is to have two channels, both kernel and user space, that can provide the same capabilities depending on where's the application running.
Yeah.
Today it's not the case. Today they are a little bit different, just because the organizations are different and the pace of acceptance is a little bit different. But overall, and this is kind of the strategy, the target is to have more or less the same.
Yes. And there is, of course, switch dev as well, which make things even more interesting, which is yet another mechanism.
Yeah, switch dev is more relevant for the full offload where we want to provide a switch or a router interface to configure rather than the partial offload, which look into an interface level kind of.
Yeah. So many options to make things even more complicated than they are.
If I may just add two more comments. Mellanox is doing a lot of effort to try and get into the 5.1 release. We really hope and believe that we will be able to merge all the changes there. It looks like it's getting together nicely. So hopefully it will be in the next 5.1 release, which I understand is a little bit delayed, but hopefully it will be there, and if not, it will be in 5.1.1.
Sure.
And around performance, I agree that we're still in the evaluation phase, but just to give everybody a ballpark number, we're looking at a few tens of percent, probably 30 to 50, maybe a little bit more, a little bit less, depends on the use case of acceleration compared to non-accelerated use case. So those are the kind of numbers that at least I'm aware of.
And you have seen it in the full stack with orchestration and the controller?
We have seen that in micro benchmarks where we provisioned with OpenStack but not with real VNF use cases.
Okay. Because just the vRouter on its own, we have seen without anything on top, so running the vRouter and programming in advance the flows, we have seen very good numbers in 3 digits actually, percentages. Yeah. But again, when you put the full stack, things change dramatically.
Yeah, so tested with the full open stack
Yeah.
risk, but not with a real VMF. It was just forwarding benchmarks.
Yeah. At this point, that's all you do. You pump packets into the V router, then up to the VM and down, and we use something like layer 2 forwarding or test PMD or something like that,
Exactly.
which just takes packets from one interface to the other.
Exactly.
Yeah, and then we need to see what happens in production.
Regarding the work you say is kind of going on, you still can't disclose sort of the improvement that you saw with the partial upload. Right? When do you think you will have some numbers? Is it like sometime in January, February?
Numbers?
Yeah, like what kind of?
My team has numbers, but we need to sanction them with the official performance team in Intel. This can be tricky because we need to put it in the backlog and they need to prioritize. And but I'm hoping soon, at least the V router on its own, we should be able to have them in Q1 2019. I'm pretty sure we will. Yeah, but no promises. It's not in my hand.
That's fine.
Yeah.
I'm not going to hold you on that.
Okay. You can always send me an email and say, is it ready yet?
Okay.
Okay. Thank you very much.